All right, so let's go ahead and look at an example to introduce you to this idea of a random variable. So I went ahead and started this recording here, and if you look at the first example on your packet of slides, you'll see that we're considering a dice game. So in this game, we're going to roll the dice, and we're going to get no points if we roll a 1, 2, or 3, 5 points for a 4, and then for a 4 or 5, excuse me, and then 50 points for a 6. And it asks us to find the expected value. So if I walk up to play this game, how many points can I expect to get? And what is the standard deviation? So what is a measure of spread that's associated with that expected value? So I'm going to go ahead and label letter Y as my random variable, and that's going to represent the number of points. Now this random variable Y can take on 3 different values, all right? And those values are 0, 5, and 50. So those are my 3 different point values, okay? But it also depends on what I get in my roll. So if I roll a 1, 2, or 3, I get no points. If I roll a 4 or 5, I get 5 points. And then if I roll a 6, I get 50 points. Okay, but each of those scenarios, each of those outcomes is not equally likely. So we actually have another value here that I care about, which is the probability that each of these things is going to happen. So what is the probability of rolling a 1, 2, or 3? Well, there's 6 total numbers on this die, and so 1, 2, or 3, that's going to be half, so 3 out of 6. 4 or 5 is going to be 2 out of 6, or a third of the time. And then for 6 out of 6, that's going to be just 1 for the number 6. All right, so if we want to find the expected value, then we're going to go ahead and take each of those 3 possible outcomes of 0, 5, and 50 and look at their probability that they would occur. So for the work here, you can use mu again for the mean or the expected value, or you can use the expected value, so capital E, of your random variable Y. All right, so either one is fine. Don't need to use both. I'm putting both, but you only need to use one. So the expected value is going to be 0 points times the likelihood of that happening, which is half, plus 5 points times the likelihood of that happening, which is a third of the time, and then 50 points times a sixth, because that's the probability that that will occur. And so when you do that math, so that's 0, that's going to be 2.5, and then plus 50 over 6, and so that's going to end up giving you 10 points. All right, so that is our expected value there, 10 points. Okay, and then it also says that it wants us to find the standard deviation. So go ahead and just let that sink in for a little bit. It asks us to find the expected value. We found all in this little table here that I made. We found all of the possible outcomes of our random variable, and then multiply them by the likelihood of them happening. All right, so we get 10 points for our expected value. On the next slide, all right, which is, actually, I'm going to go back to this previous slide. I'm going to keep going and extend the page because I need to find the standard deviation. Now, we're always going to first find the variance. Now, if you think back to when we did this with chapter 6, a long time ago, I promised you would never do this again by hand. Well, I guess I lied to you because we're about to do it again by hand. But again, I'm going to show you later on in the calculator so you never have to do this again. But for the variance of our variable Y, we need to find the distance from our expected value for each of these. So 0 minus 10, 5 minus 10, and finally 50 minus 10. So we need to find the distance from the mean for all of my possible values for my random variable Y. Now again, because some of the first 2 are going to be negative and the last one's going to be positive, we don't want that to mess it up, so we square all of these. Hopefully that kind of reminds you a little bit. And then because again we're dealing with not equally likely values here, we need to multiply by their probabilities again. So 3 6, 2 6, and then 1 6. All right, so I'm going to use all of that and go ahead and go to my calculator. So I can go ahead and show you how I'm going to do this. So I'm just going to have calculate page, and I'm going to type in my 0 minus 10, and that's going to be squared. times, and this is my 3/6 here, so I'm going to use 0.5, plus, we have our 5 minus 10, again, minus 10 because that's our expected value, squared, and that's times our 2/6, so I'm going to use, just for fun, I'm going to use the fraction, which is controlled division, and type in 2/6. And then finally, plus 50 minus 10 squared times 1/6. So again, just for fun, let's go and use the fraction to give you 1/6. Oh man, did so much awesome work that took us across the thing. That's great. So hit enter. And again, this is not the standard deviation, right? Again, we had to square everything so we didn't have to worry about the positives and negatives making 0. So since we squared everything, this is the variance. So this is actually 325 squared points for our variance. So 325 squared points. I don't want squared points, right? We don't want that, so that's squared points. We want to have just points. So if you remember how to find the standard deviation, we're going to go ahead and take the square root. So we're going to write, you can use sigma if you want. Again, this is a model. Or you can use the standard deviation, so SD of y. Either one's fine. So that's equal to the square root of 325, which, if you round, is about 18.03 points. So the expected value of points each time I play this game is 10. And then the variability of that, so the standard deviation of that, is about 18.03. So this shows a pretty decent wide range of possible values. Again, your possible values are 0, 5, and 50. That's a fairly wide range. All right, so that's the first one there, finding the mean, or the expected value, and standard deviation. So 10, and then 18.03. All right, let's continue. It says to find the new expected value and standard deviation if we double the points. So instead of having 0, 5, 50, now we're going to have 0, 10, and 100. Again, we still have our, this is when I roll a 1, 2, or 3, this is a 4, 5, and this is a 6. Probabilities haven't changed, right? The probability of this hasn't changed. This is still going to be a half or 3/6. This is 2/6. And 1/6. So nothing has changed in terms of the probabilities. All right? But now when I find my expected value, I don't just want to find it of y, my random variable y. I want to find it of 2 times y, which is doubling it. Now you can go ahead and do the same thing we just did, which is the 0 times 3/6 plus the 10 times 2/6 plus 100 times 1/6. But you probably don't need to do that. You probably can think about this and just think, well, if I'm doubling every value, what am I going to do to the expected value? I'm going to double that as well. So it's also going to be 20 points when I double it. Okay? Now for the variance. Now this is a little tricky because a lot of students will get this wrong and they'll just double, the standard deviation, they'll just double the 18.03 number, which is incorrect. So if you want to find the variance of double the number of points, you actually, because we're dealing with squared units, we need to square that 2 and then multiply it by our 325. Okay? So it's really like we're doing 4 times 325, which is 1,300. Again, that's squared points. We don't want squared points, we want just points. So I'm going to use sigma, or the standard deviation of double the number of points is going to be the square root of 1,300, which is about 36.06 points. Okay, so key thing to remember here is whenever you're finding standard deviation, you always want to deal with variances. Always work with variances. Never work with standard deviation. So always work with variances. I promise that's going to help you a lot. So there you go for this second idea of doubling the amount of points. All right, now, what happens if we just play the game twice? So we're not just playing it once for double the amount of points, but I go back to the original and I play the game twice. So that means I want to find the expected value of playing the game once. So I'm going to put y sub 1, all right, and then plus, what if I play it a second time? So y sub 2. Make sure you put y sub 1 and y sub 2 to show that they are independent events here, right? The idea is that if I roll the dice and I get a 5, that doesn't actually change the likelihood of me getting 1, 2, 3, 4, 5, 6 on the next roll. So just keep in mind they are independent events. All right, so to do that, you can always just add each of these. So you're going to add the expected value for the first event plus the expected value for the second event. Again, it shouldn't matter what you get on the first roll, so it's just going to be 10 plus 10, which is also 20. So 20 points for that expected value. Now, here's kind of the interesting part here. To find the standard deviation of two independent variables, our y sub 1 and y sub 2, we always want to deal with variances. Okay, and so we're going to add variances. So I need to find the variance of the first one plus the variance of the second one. Now, we already found the variance of each of these in the original, and the variance in the original was 325. So I have 325 plus 325. So I'm going to get 650 squared points. Again, I don't want squared points. I want just points. So I'm going to use sigma, or the standard deviation of our two independent events is going to be the square root of 650, which is about 25.5 points. All right. Okay, we're almost finished. Just one more to think about. This was asking if we had the expected value for playing the game twice. Okay, so playing the game twice. All right, so now we want to look at what if you and a friend both play, and instead of talking about adding them up, which we did basically with doing it twice, we need to look at the difference. Okay, so that means, I'll just give you an example. Let's say friend 1 and me. Friend 1 and friend 2. Friend 1 and me. So friend 1 can get a 0, a 5, or a 50. And I can get a 0, a 5, or a 50. Alright? So again, you could take each of these and subtract them, so you could have anywhere from negative 50 all the way to 50. Right? Those are your possible values. Alright, and then you multiply them by those percentages. But again, we can just think about doing this as two independent events. So y sub 1 and let's say on y sub 2. So we're going to just do 10 minus 10 equals 0. So the expected value for the difference between my friend and myself is going to be 0 points. Again, his expected value is 10 minus 10, so when you subtract, you get 0. Alright? Now, this is the hardest thing kind of understand. What should we do about the standard deviation? Well, I told you we're always going to deal with variances, so we're going to work with variances, and students will just subtract the variances. Alright, so they'll say, oh, well, the standard deviation is also 0, because 325 minus 325 is 0. But here's the issue. The issue is that the range of values goes from, let's say, I get 0 and my friend gets 50. So 0 minus 50 is negative 50. Or instead, let's say my friend gets 0 and I get 50, and when I subtract, that's 50. Well, what is that range of values there? That's 100, between negative 50 and 50. And on the previous problem, if I was adding them, I could go anywhere from 0 to 100. And what do you notice about that range of values? It's the same. So even though we're subtracting, you're always going to add the variances. So you want to write this and put a bunch of exclamation points, maybe even get it a tattoo next to your slope-intercept form tattoo on your right arm. Variances add. Variances add. No matter if you're subtracting or adding your independent random variables, you always add the variances. So it's actually going to be just exactly the same as the one we just did. So our standard deviation for a subtraction of these two events is still going to be 25.5 points. All right? So hopefully that gives you an idea of what we're doing here. So we're finished with this problem. The main thing is you always want to add the variances. And I'm going to go ahead and stop now, and I'm going to give you another video lecture that explains a little bit more about why we should add the variances.